Assalamualaikum warahmatullahi wabarakatuh to Dr. Izani. My name is Muhammad Afiq bin Muhammad Shukri, metric number GS73640, and today I'll be presenting about my mini project, which is the fixed wing aircraft project. So for this is the abstract for my technical report. I highlighted several findings in this report, and for the contents of the report, there is two main part for this report. First is about the performance analysis of the steady flight, and also second is about the performance analysis of accelerated flight. All right, so moving on to the introduction, I have selected F-16 Fighting Falcons by Lockheed Martin as my selected aircraft. So let's have a quick look on the problem statement and objective of this project. So the problem statement is that because modern aircraft are getting more complex day by day, so it is essential for engineers to understand this very classical analytical methods. And this project is to address the challenge of evaluating fixed-wing aircraft performance using established theories and simplified mathematical models. So the objective of these projects are first to analyze the steady flight performance of selected aircraft, second to evaluate the accelerated flight performance, and third is to develop a structured and a systematic technical report that demonstrate understanding of the fixed-wing aircraft performance. And the scope of these mini projects are limited to only analysis of a single fixed-wing aircraft operating under standard atmosphere, and the analysis covers both steady and accelerated with simplified aerodynamics and publicly available aircraft data. All right. So moving on to my selected aircraft overview. So this is the overview of the F-16 Fighting Falcon aircraft. It's a combat aircraft. So this is the geometry, and this is the basic specification of the aircraft that I have obtained from reliable sources, mainly from the textbook. Some important parameters are like the maximum takeoff weight, the wingspan, the wing area, the aspect ratio, and talking about aerodynamics, about its CD has to be assumed. CD, CL, and K are assumed values was taken from reliable sources from the internet, and also it's about the power plants and the performance parameter as well. All right, next is about the mission profile. So since this is a combat aircraft, so it missions involve both air-to-air and air-to-ground operations. So this is the typical mission profiles for high, low, high missions, which is suitable for F-16 aircraft. So it is essential for us to understand the mission profile because it provides us a clear operational framework for the flight performance analysis later on. All right, so steady level flight. On steady level flight, what I assessed was that because for steady level flight, lift is equal to weight, thrust is equal to drag. So the aircraft are in a very static position because the summation of force are equal to zeros in both x and y directions. So we establish for thrust required and power required several equations starting from the basic drag equation toward getting the thrust required as a function of velocity, power required, which is the velocity times the thrust that we gain. So this is the result for the F-16 aircraft using the data from the table 2.1. And then yes, this is projected uh, projected power from the CD coefficients. You can see this graph, which is thrust recovery and power recovery versus velocity. Okay, so next is about thrust available. What I calculated here is about the Vmax, and I obtained 493 meter per second for this aircraft. Next is about the rate of climb. So rate of climb over here is basically I got around 37.3 for F-16 aircraft, which is quite good. Endurance and range performance. So endurance I got around 3.8 hours. All these calculation are also with several assumptions have been made that I have explained inside the report. And also the range is around 2 km, which is consistent with typical F-16 combat radius. All right, now let's move on to the flight performance analysis, which is the accelerated flight. So accelerated flight, we need to say it's not statics anymore. We have extra movement, extra force, and this is illustrations of F-16 on max speed run. So talking about level turn, so it's considered as an accelerated flight because it have angle component to balance with the weight. So, yep, let's start with the basic equation first, understanding about the level turn, and then we got the turn radius and turn rate. So turn radius around 700, turn rate around 19.2 degree per second, which is quite good. Okay, accelerated rate of climb. So accelerated rate of climb is basically excess power divided by weight. So this is the result that I got, around 70.5 meter per second. Next is about the takeoff performance. So takeoff performance, takeoff, it is a summations of ground roll and airborne distance. As you can see inside the picture. So this is also some illustration about intermediate segment of the ground roll. We have several important velocity to be considered: Vstall, V1, VLFR. So some important parameters have been calculated inside the report. Okay, so yep, it's also we have to consider into account the airborne to clear an obstacle. So because this is required to calculate our airborne distance, because it will affect the calculation. We need to calculate the theta, the obstacle clearance angles, so we can get the airborne distance and the total takeoff distance for this F-16 case is around 1.2 km, which is the summations of ground roll distance and airborne distance. Okay, so next is about the landing performance. So this is the visualizations of a landing performance. Okay, so what we have here is the approach distance, flight distance, and ground roll distance, free roll distance, some important parameters that we have to consider. So this is the geometry of the landing flare. We need to calculate the flare radius, the R over here, the flare height, HF, approach distance. So this is clearing, this is a typical data. In feet is around 50 feet. I convert into meter is around 15.24 meter to clear an obstacles. So flare distance, we can calculate flare distance from the calculation we have made. And then to calculate ground roll, we can use equation from Anderson textbook, equation 6.119, and with also some assumptions about the braking coefficient mu r is equal to 0.4. So yep, I calculate first to get the ground roll because we have calculated the flare distance, the airborne distance, and finally we can get the total landing distance, which is equal to 1.7 km, which is quite good. All right, so we come up to the conclusions of this report and the reflections. So for me, performing this project was a very invaluable learning experience because I get to see a picture to bridge the gap between theoretical academics into the real world, yet to apply the knowledge into the real world. And what I found that aircraft design is limited. We have limited trade-off. We cannot get everything. If we want to design a fighter aircraft, we have to sacrifice the capacity to bring people, etc. We cannot have everything to design a certain aircraft. It's very strict towards what we want, what mission the aircraft is crucial for. And from the study as well, we can see that since F-16 aircraft, it has quite good thrust to weight ratio, so it will result to a very good rate of climb, which is around 7.3. Yep. And then since It's the wingspan also is like slightly low, so it have a very good banking angle, which assume and accurate with the established data. So I guess this project was a success, and it's able to achieve its objective to provide me an understanding based on the analytical approach analysis of the flight performance. With that, I end the presentation. Thank you so much.